Hello, my name is Brandon,
My name is Patrick.
and we are here at Odessa College.
We are doing a project for engineering dynamics. We'll be using the velocity and angular velocity formulas, as well as the gear ratios, to find the angular velocity of the spur gear, as well as the angular velocity of this OA bar.
So to start out, we need to determine the angular velocity, not the angular velocity, but just the velocity at r. And to do that, we're going to use the equation velocity equals omega times r. So and so omega r ends up being 20 radians times 0.25 is the radius, and that ends up being 5 meters per second. And then we need to find the velocity at h of the hub gear here, and that is going to be omega h times its radius. And when we plug that in, omega h is 5, and the radius ends up being 0.15 meters, which that comes out to be negative 0.75, and it's a negative because the hub gear is actually spinning in that direction. So
And then to find the angular velocity of the spur gear, we're going to be using the gear ratios as well as similar triangles to set up our formulas. And those are going to look like this. So we have the velocity of the hub right here over x equals the velocity of the ring over this right here, 0.1 minus x. This comes from the diameter of the spur gear, and then just labeling this x, and then the remainder is here is 0.1 minus x. And then plugging in our numbers, we have 0.75 over x equals 5 over 0.1 minus x. Cross multiply gives us 5x equals 0.75 times 0.1 minus x. Distribute that 0.75, so we have 5x equals 0.075 minus 0.75x. Move this x over, we have 5.75x equals 0.075. Solve for x, we're going to divide both sides by 5.75. So that gives us x equals 0.0130 meters. And then using this, we know that the angular velocity of the spur equals, we're going to use this here, VH over x. Now that we have the VH and x, we can plug those in. So that's 0.75 divided by 0.0130, which gives us 57.7 radians per second.
And so now to find the velocity at A, we need to use the x that Patrick found as well as omega s. And in order to do that, we will use the equation VA equals omega s times the radius of s minus the x. And so omega s was 57.7, and the radius is 0.05, and the x is 0.0130, sorry. And then when you compute that, it's 2.1349 meters per second. And now in order to find the velocity of the OA arm here, the angular velocity of the OA arm here, that is going to be omega OA is the ratio of the velocity of A over the radius of the OA arm. And the OA arm here is actually 150 meters plus 50 meters. So we put that together and we have 2.1349 over, that was 0.2, and that ends up coming out to be 10.67 radians per second.